All right, hey, we're back here with period one. Hello, period one. How you doing?
Hello.
All right, so we're going to try to go over 36 and 37. We'll see if we get to that. First off, we've got to balance this equation on here. We got a combustion reaction. So let's see. We've got 3 carbons over here in this propane. So we'll start off by putting a coefficient 3 there. Then we're going to balance the hydrogens. We got 8 hydrogens. So we're going to have to do 4 times 2 over there. All right, now let's see. 3 times 2 is going to be, is that 6? Is that right? 3 times 2 is 6 oxygens there, plus another 4 over here. So that's going to be, is that a total of 10 oxygens? We're right so far? 3 times 2 is 6, plus the 4 here, which makes it easy. We just need a coefficient 5. This becomes a 1. Can you agree? Is this the balanced equation now?
Yes.
Do that real quick. That was nice that we didn't have to go multiply everything by 2. All right. Now that we got a balanced equation, by the way, you're not going to have to do that on the test, but it was just a little nice review. How many grams of CO2 would be produced? This is what we're trying to find. Grams of CO2, find, and grams. From the combustion of 3.5 moles, so this is the given, of C3H8. So this is the given, and it's nice. It's already at moles, so we don't have to do the big full 3-step. We just need to do the given over 1, which is 3.5 moles of C3H8. And let's see, group 5, can you help me out? What's 12 times 3? We need to oh, wait, I take that back. We don't need to do the molar mass. I already started doing the wrong thing. We're at moles already. We just need to do the mole to mole ratio. So, could you help me out, group 5? How many moles of the chemical we're trying to find are there in the balanced equation? So it's labeled right there. That's what we're trying to find. How many moles of that chemical are there in that balanced equation?
3.
There's 3 moles of CO2 in the balanced equation. Group 6, how many moles of C3H8 are there in the balanced equation?
1.
Just 1 mole of C3H8. Those two diagonally cancel, so that's good. Now at this point, we've got moles of CO2. We need grams of CO2. And let's see, 1 mole of CO2 is how heavy? All right, group 7, how heavy is carbon?
Carbon, that's
12. And then oxygen is 16. We've got 2 of them. What's 2 times 16?
32.
What's 32 plus 12?
44.
All right, molar mass is 44. So you've got to do the given times 3 times 44. Okay. How much?
462.
Yeah. Anybody else get 462?
Yes.
Okay, so we ended up with 462 grams of CO2. Cool. Now let's see. Solve for grams. Write the balance. Oh, okay. Sorry, I jumped ahead over there, didn't I? We already solved for grams of CO2. Done. Now we got to solve for grams of O2. So, coming back, now our given is going to be grams of O2. So I'm going to erase the given from propane, and this is our given now. And the given is in grams. Now we do need to do a full gram to gram. We're going to have to start over here, divide by molar mass, mole ratio, and then multiply by the molar mass. So let's see, our given is still, okay, the problem's still going to be the same. We're still starting with 3.5 moles of C3H8. Or if you, yeah, okay, and then moles of C3H8. We still have 1 mole of C3H8 in the balanced equation. But we've got to change it into, now we're trying to find O2. Group 7, how many moles of O2 are there in our balanced equation? That needs to go on the top. Okay, there's 5 moles of O2. Moles of propane will cancel out. And now let's see, we've started there, we've jumped over to here. We just need to multiply by the molar mass of O2. Group 8, 1 mole of O2 is going to be how heavy? What's 16 times 2? All right, anybody else? Because group 8 is either in a coma or they're so focused. 32 grams of O2 is 1 mole. All right, so what is 3.5 times 5 times 32?
560.
560?
Correct.
560 grams of O2. All right. Okay, so next one. What do we got? Limiting and excess reagents. All right, so let's see here. We've got, if we have 3 moles of aluminum and it's mixed with 5.3 moles of chlorine gas and it reacts, here's our equation we'll be needing to use. And I think on page 379 of your textbook it went over this. What's the limiting and excess reagent? And then we got to calculate the moles of the excess reagent. Okay, well what's nice is they already start with moles of these. And so I'm just going to start, since this is the smaller one, what I'm going to do is, here's a way we can do it. Let's see how many, if we start with 3 moles of aluminum, how many moles of chlorine do we need? And then once we get that answer, we can see, do we have enough chlorine or not? So we're going to start here, 3 moles of aluminum over 1. This is one way we can do it. And we want to see how many moles of chlorine we're going to need if we're reacting that much. So we need the mole ratio, find over given. And let's see, since aluminum, how many moles of aluminum do we have in that balanced equation?
2.
2 moles of aluminum. And let's see, we want to find how many moles of chlorine are in that balanced equation?
3.
3 moles of chlorine, Cl2. So that'll cancel. And what's 9 divided by 2? 3 times 3 is 9. 4.5 moles of Cl2 are needed. Now, coming back to our equation, do we have at least 5.4 moles of Cl2? In fact, we have more, don't we? So that means since we have more moles than we needed, that Cl2 is going to be the excess. We've got more than we need. Cl2 is excess. And since it's excess, that would mean that aluminum is our limiting reagent. Al is limiting. Okay, so that was one way we could figure out. So, and the reason I started with aluminum, I did the one that was just the smaller number of moles. Now, if they'd given you grams on these, you would have had to change these to grams. Then you could have done this. So now we want to see how many moles of the excess reagent, that's Cl2. Well, let's see. We know we had 5.3 moles from the problem of Cl2. We only used 4.5. 4.5 moles were used. Can you do your math magic for me there with the calculators? What's 5.3 minus 4.5? And that'll tell us how much chlorine would be left over. Moles of chlorine remaining. What did you all get?
0.8.
0.8 moles remain. Okay, I agree with you on that one. Okay, you know what? We've got time. We're going to do 38, and then I'm done with all of these. So let's see, what do we got? We've got a rocket fuel, hydrazine, really nasty stuff. If you spill it on you, it's like wash it off quick or your arm's going to dissolve. Mixes with oxygen, okay? And let's see, what is the limiting and excess reagents if 1,000 grams of hydrazine reacts with 1,000 grams of oxygen? Okay, so we can do a couple of things. We can start off, if you wanted to, with 1,000 grams of each and try to figure out how many moles of those are made. Or what we can do is, I'm just going to start with this one, 1,000 grams of hydrazine. Okay, N2H4. Put that over 1. Let's go on this and let's see, how do we want to do this? What's going to be the easiest way? What's going to be the best way to do that? Let's just figure out how many moles of O2 we're going to need with that. So let's just change this. Let's see how many moles of O2 we need. So we got 1,000 grams of hydrazine. And let's see, we got to figure out how heavy is what's nitrogen times 2? That's going to be 28. And then we got 4 hydrogens. What's 28 plus 4? 32?
Yeah, 32.
Wait, 32 is the total. Okay, so 28 plus 4 is 32, you're telling me?
Yes.
Okay, I agree with you. 32 grams. And that'll be 1 mole of hydrazine and 2H4. So those cancel out diagonally. We know we set it up. And our mole ratio, since we're trying to find moles of O2, how many moles of O2 are in that balanced equation? That's what we're trying to find, moles of O2. And then how many moles of hydrazine are in the balanced equation? It's a 1-to-1 ratio. N2H4. Moles cancel out. And how many moles of O2 do we have? 1? I don't think so. We've got 1,000 divided by 32. It's not going to be, oh, I'm sorry. No, we got it. Moles of O2. You've got to do the math now. What's 1,000 divided by?
35.
How much is it?
31.35.
31.25 moles of O2 are needed. Okay. So let's see here. What's the limiting and excess reagent? So we know how many moles of O2. Let's see how many moles of hydrazine we have. So we figured out how many moles of that we need. So let's start off. We've got 1,000 grams of hydrazine, N2H4. We want to change that into moles, because let's compare and see how many moles we have. We already know that hydrazine weighs 32. 32 grams of N2H4 is 1 mole of N2H4. So wait a minute, what's 1,000 divided by 32? 31.20. Am I off the page? Or am I still on there? Moles of N2H4. So we've got 1 mole of hydrazine and 1 mole of O2. Isn't that exactly how much we need to do the reaction? Yes. 1 mole of this. So since we have 1 mole of each, is there an excess reagent?
No.
There's not. No excess reagent. Because they're in the same proportion. A 1-to-1 ratio. We have 31 moles of that and 31 moles of that. Okay, we're done.